Hello, everyone. Welcome to the Fundamentals 2. Okay, last class fundamentals we, we stopped in certain place. We are talking about physical and chemical changes. Okay, physical and chemical changes. So, what are the physical and chemical changes? So, physical means melting, like melting, boiling. These kind of phase transition are called physical changes. Okay, chemical changes means a complete transition. Like, for example, if you take water molecule and then you dissociate into hydrogen and oxygen, this is a chemical reaction, because what happened in the water is you broke the bond between hydrogen and oxygen here, and then you made two hydrogen molecules, and then you made two oxygen molecules. You have to balance this reaction anyway. But simply saying you have to break the bonds, breaking bonds happen in chemical reaction. This is very, very important understanding. But in physical, it doesn't happen. If you take water from solid, you just melt to liquid. Okay? Due to temperature changes, it just melts from solid to liquid. No bonds are broken. No bonds are broken. Okay, this is very important. But changes are also visible, right? So you have to see between, like, if you take paper, okay, you take a paper and then you rip the paper. You take a paper and then you rip it off. So this is just a physical change. But if you burn a paper, so the paper is going to burn in oxygen, and then it's going to form carbon dioxide and impurities, right? So this is a chemical reaction. So in chemical reaction, the changes are visible. So like you might see some color changes. You will see color changes happening. You will see temperature changes. The heat might increase or it might decrease. So the heat might get released, or the heat might be absorbed. Okay, there might be gas evolution. So you will see some bubbling reactions, or a precipitation reactions. That precipitation means a solid formation can be seen. So these are all identification for chemical reactions. But in physical reactions, is very simple. Okay, it looks, there is no bonds are broken, no phenomenal changes are seen. Now, in the properties, we classify the properties into two of them. One, we call them the intensive property. One is called as intensive properties, and another one is called as extensive property. What is intensive and extensive? Intensive means the amount of matter the amount will not affect the property. The amount will not affect the property. Okay, so let's take honey. If you take honey and you take 1 gram or 100 gram, the density is going to be same. The density remains same. But the extensive property, if you call mass or volume, length, shape, these things, if you add the amounts, if you add more amount, the length is going to increase, the shape is going to increase, or volume is going to increase, the mass is going to increase. The amount affects this property. Okay, the amount affects this property. Okay, so the density is not the only example. If you have conductivity, malleability, ductility, all these things are intensive properties, because it does not matter. If you take an iron, whether you take a small piece or a very big piece, the conductivity is going to be the same thing. The malleability or the conductivity, the amount the strength you need to bend or to squeeze is going to be the same. So basically, it is not going to get affected by the real properties. The intensive property will not affect them. Okay. So if you want to test the chemical properties, you have to take reactions. You have to subject any substance. You take a substance and then you react the substance with acid, a base, you throw it in water, and you you keep it in air for some time. Okay, you soak some chemicals to see what happens, right? You heat and see what happens. These are the things that you can see, that how they interact, how they react will tell you uh, whether the substance have chemical reaction. So that can easily tell us what this is. Now, coming to the next part of this section, the fundamentals, is understanding accuracy and precision. This is a second set of topic that I believe it's very important from learning chemistry. So what is accuracy? So you have accuracy means if I have asked you to throw a dot on a certain place, let's say this is NJ. So I ask you to throw a dot on this. But you threw, instead of New Jersey, you threw, let's say this is Boston, you threw here. This is considered as a precise value. It is a close value. Okay, this is a precise value. This is the accurate value. This is what we want. Okay, this is a precise value. But let's say the dot you threw landed here, somewhere here in Florida. This is both inaccurate and not even precise, right? So accuracy means the correct value. Okay, so if you want, if you want to get 100 in score, 100 is the maximum score. This is the accurate value. But if people get different values, let's say they get 97, 98, or 94, or these called precise values. Okay, so we should understand this precision versus accuracy. Okay, so very clear understanding should be there. So because this helps you to understand significant figures very well. Now, we use commonly in lab, we use two things. One is called as the percent error. How to calculate percent error? The percent error can be calculated using accepted value, right, minus experimental value divided by the accepted value. I'm going to write AV and EV from now on. Okay, times 100. Let's say the accepted value for the test, we have to get 100 out of 100. What you got is 80. The accepted value is again 100. And if you get another multiplied by 100, what is the error? The error is only 20%. So this is very simple. Okay, so we are just using, this is the value that you got, right? The experimental value. The second one is to understand the percent yield. Percent error is different from percent yield. Percent yield means how much you got when you make a reaction, right? Or the amount that you really got, right? This is experimental value divided by the overall value times 100. For the test, the overall value is 100. This is what you should supposed to get. But what you got, experimental value is 80. Multiplied by 100 is once again 80%. So what you got is only 80%. Right? This can vary. This is not going to be 100. Let's say that the overall test score is going to be 40. And you got a 35. And you have to multiply by 100 to get the final value. So these are very important we use in chemistry. Okay, so you should be aware of these fundamental concepts. The next one is using the SI and the metric system. In the SI and metric system, we use physical quantities. Okay, we are going to use only the common physical quantities. Okay, the first quantities that's related only to chemistry. We are not going to jump from all the physical quantities. Okay, and then there is a unit for this, and there is a specific symbol also for this. Let's take if you take mass. Mass. So the unit for the mass is kilogram. So you have to change everything into kilogram just to make sure everybody follows a certain standard. So the symbol is kilogram. Kids. For length, this meter. So meter. For time, this is second. For temperature, it is Kelvin. So these are the major ones that we encounter during chemistry classes. Okay, we are not going to do anything beyond this. Okay, and the most important conversions are very important. So the conversions, everything goes by in terms of all multiples of 1000. Okay, it's very easy to remember all multiples of 10 to the power of 3 or 1000. So you have to remember this all the time. Okay, 1 kilogram. 1 kilogram is 1000 gram. 1 gram is 1000 milligram. And 1 milligram is 1000 micro. This is a symbol called micro. Okay. The same thing, 1 kiloliters is equal to 1000 liters. 1 liter is equal to 1000 milliliters. 1 milliliter is equal to 1000 microliters. Okay, so you should always use what is called as dimensional analysis to solve this. Okay, dimensional analysis is a separate topic. I will go over this, okay, in detail. Okay, so this is very important. Excuse me. This is very important to go over to calculate. When you do conversions, you have to use dimensionals that you get the correct answer. Okay, it's very important. The next one is what is called a scientific notation. Okay, scientific notation is also important. I have a set of things that we have to go over. Scientific notation if you have a to the power of 10 to the power of x, this a is called as the. If you use a calculator, sometimes it will show like this. Use a calculator. It will show if the general number is 5 into 10 to the power of 6, the calculator will show 5 e power 6. Okay, the e is nothing but this 10. Okay, so it should be aware of this. Okay, so if we have scientific notations from normal standard, let's say the number is 28,300. This has to be converted into scientific notation. So you are not, if this is a big number, usually we change that number into easily handle. The number can be easily handled. So 28,300 can be written as 2.83 into 10 to the power of 4. So this is called as the scientific notation. But if the number is, if you reverse it, it's called a standard notation. If the number is 8.81 into 10 to the power of minus 4, if you write down as point, if you move this 4 places, and then you write 0.000881. So there are 3 zeros I have added, and there is 1 8 already there. So if this is 1, this is called as the standard notation. You should know, and you should practice this enough with several problems just to make sure that you have a very clear picture about how to do this. Okay. And there are also standard rules when you use this scientific notation. Okay. Let's look at some examples for addition and subtraction. Okay. Let's look at some example of addition and subtraction. If you look at addition and subtraction, so if you're going to add two numbers, 2.0 into 10 power 3 and 3.0 into 10 power 4, you're going to add this number. But now you can look at this number as one of this number has a 3 as an exponent and another one has 4 as an exponent. But we have to make them even now. So how to do this? You have to change this thing, whole thing. Okay, so we have to change this. We have to change this as 0.0 into 10 to the power 4. And then we have to keep 3.0 into 10 to the power 4. And then now you add as 3.20 into 10 to the power 4. Okay, so then only you can easily add them. So you have to, the main rule is to bring both the exponents same. So when you multiply, so the rules in algebra is a power x times a power y. You always add a power x plus y. And is a power x divided by a power y. If you divide two numbers, you always subtract them, a power x minus y. So this you should know. So when you multiply, exponents are added. When you divide, exponents are subtracted. Okay, so this means, so we, if you take two numbers in the multiplication, 4.1 into 10 power 3, and you're going to multiply by 2.0 times 10 power 10. Now, if you multiply, you just multiply these two numbers to get 8.2, right, into 10 power 13. So you added 8 plus 1, right? So when you divide, you do the same thing, right? 6.8, let's say 6.8 into 10 power 8 divided by 2.0 into 10 power 5. You divide these two numbers and then you subtract. 8 minus 5 is 3. So this is how you do use the scientific method. Now let's go to the next one called using measurements. How to use measurements. This is also very important. So I'm going to show you some examples of the measurements. Okay, so then only we can understand this very clearly. Let's say there is a, so there is a cylinder, and then you see the liquid is filled to certain capacity. Okay. So it is filled between 3.3 and 4. Okay. So you never know exactly where you are. So it is between 3 and 4. Okay. So let's say, so the number is 4 and the number is 3, and then the liquid is filled till here. So here then you are unaware of whether this thing is whether it's 3.5 or 3.6. So you have to take a rough guess here. Okay, so if when you take a rough guess, we call this as uncertainty. Okay, so we have a problem with certainty and uncertainty. Okay, so if you know a number, then you can predict a number. Okay? So if you don't know a number, then you have to stop right there. So we have to go always with the less precise number. Okay, we use this often in the lab. So if there is markings, like it says 3.1, 3.2, and then if specifically say 3.3, you are going to use 3.3. But if this number is between 3.3 and 3.4, and you see the meniscus is like this, now here in this case, you are going to guess another number, 3.45 or something. Now this is going to be an uncertain number now. So uncertainty will come at any point when you don't know. So when you know, you specifically write. When you don't know, you have to guess this number. Okay, so this guessing is allowable guessing. Okay, so that is very important. We are going to look over this uncertainty in detail later on, but you have to know that in measurements you have uncertainty. But this uncertainty, we are going into a very important concept called significant numbers. Okay. The significant numbers, what are significant numbers? When you have any number, let's take, I'm talking about a number called $325. Now we know that all these three numbers are significant. Okay, so all the three numbers are significant. So these are all, the rules are all non-zero numbers, all non-zero or significant. The second rule is the sandwiched zeros is also significant. Let's say that I have to give you $305. So there are three significant numbers. I'm not going to remove the zero and I say I am going to give you $35. So 305 is a significant number. All the leading zeros. Okay. Now let's look at this leading. Let's look at the trailing zeros. The trailing zeros are also significant because it makes our life easy. So let's say that I have to give you $3,000. There is only one significant digit here. Okay. There's only one significant, but I have to give you this. All these are predominant because there is one significant digit because I can write this into 3.0 into 10 power 3. Okay. So this can be written into a scientific notation. Okay. So that is the reason I'm saying the significant digits is 1, but the zeros are significant. But the trailing zeros, the leading zeros are always non-significant. So this is very important. They are non-significant. Let's say that the number is 0.0003. So if this is the number, then there is only one significant digit here. But they are not significant here because they are all on the front. It doesn't make any meaning. So this is very important because I can write this as 3.0 into 10 power minus 4. So understanding the significant figures will give you a clear picture of what is there in what are the knowledge behind significant figures. Because why we have to use significant figures, that is a question. Because in the exams, usually in the test, you might get question and you have to answer based on what is the question is saying. So let's look at some example. Addition and subtraction. So this is connected to the less precise value. Okay, so this is connected to the precision accuracy. So let's take one example. Let's take 2.306 and we have to add 1.2 to this. So the first one has 4 significant digits. The second one has only 2 significant digits. Now I have to go with the less precise. Less precise is only 2. The one is going only 2 level deeper. The third one is going 4 level deeper. This is only the 10th place. Okay. So when I add, I am going to add and give the answer is only as 3.5. Now let's look at another example. 12,000. And then I have another value 1820.1. Now the first one has two significant values. The other one has 5 significant values. So I have to take the less precise. Now I'm going to add this number, but I'm going to round this as 14,000 because I will get 2 significant values. When you do multiplication, and division, the same thing. So let's take example 2.305 meters into 1.4 meter, you're multiplying. So this has 4, this has 2. So I have to go with the 2. The answer is 1.6 meters square. If you divide 5.305 gram divided by 1.75 milliliters, this has 4, this has 3. My final answer will go with 3.03 gram per ml. Always least precise. Okay, so less precise is the key. Now, when you want to add uncertainty, okay, so then there is an uncertainty that exists. It's very simple. Okay, so add the uncertainty as such, adding uncertainty. Let's say one of the problems says you have to have, you are measuring 2.3 ml and we are uncertain up to 0.1 ml. And then the next measurement was 1.2 ml. That one also have a uncertainty of 0.1 ml. And what is the final answer? Final answer is to add, you add both of them. The answer is 3.5 ml. You add the uncertainty as well, plus or minus 0.1, 0.1, 0.2. So just add them. But if you multiply, let's say you are having 2.3 centimeter and 1.2 centimeter. One has plus or minus 4% and another one plus or minus 2%. Now you multiply both of them, right? And then get 2.7 centimeter square. And then you multiply to get plus or minus 8%. So when you add the numbers, you add the uncertainty. When you multiply the numbers, you multiply the uncertainty. Okay, so the uncertainty is a very important one because when you have the uncertainty comes around when you say, when you add a number, then it makes sense. Like for example, when I say a person is running 3 miles, this is a certain number. When I say when he ran 3.0 miles, that means the 0 also becomes significant. When we say 3.000 miles, then these two 0 also become significant. So it depends upon when a problem says whether the significant digit, when they give significance, then that number becomes significant. Okay? If it is said it has given significance, then the number automatically becomes significant. So you should be aware of this. And the uncertainty comes when you have to add those uncertainty. As I told you, when you have a big graduated cylinder, and then Let's say this is 1 ml and this is 2 ml, and the liquid is just here. Then if you don't know, you are going to predict only to a certain level. You can say it is 1.5 ml or 1.6 ml or 1.4 ml. So this is the second digit is uncertain now. But let's look at another flask which says like this. So I am going to draw like this. So it starts at 1 ml and it's 2 ml. And then there is a line that says 1.5 ml. And then if the liquid is like this, now this number, this liquid level here given as, you can say it's 1.55 ml or 1.56 ml. Now you added, you are confident that is obviously it is above 1.5, but this 5 and 6 you are not certain. Okay, so this is what the uncertainty we are talking about. So this uncertainty you can add. You are not going to say another number 1.5, 6, 6, 7, 8. These are, you never know these things. Okay, so we are not going to add these numbers. So we are going to add only to one level more. Not when you are not aware, you are going to add one number. When you are, so you cannot extrapolate as much as you can. So this is very important. So this is where we are going to stop today. Okay, so this is a very important class 2 sections of fundamentals where we covered a lot of preliminary things. Okay, and we are going to continue for another session as well of the fundamentals, and then we are going to dive deep into understanding chemistry. Okay, this is for, so this will be very useful for honors and general chemistry before you take the A2 chemistry.